Welcome to this class on Python list as part of the Python Made Easy series based on Python 3.7. In this class, we will be covering Python lists from the very basic to some more advanced topics. So stop wherever you feel comfortable. If there's some things you don't know that are covered here, you can always go to another class to fill the void and then come back to this. But I wanted it all in one tidy little package so that if anybody wants to interrogate the topic of Python lists, it's all here for you. Let's jump in. What are Python lists? Lists are mutable sequences typically used to store collections of homogeneous items where the precise degree of similarity will vary by application. There are various different ways to create a list. We're going to go through those on the upcoming slides, but let's define some terms here. What is an iterable? An object capable of returning its members one at a time. Iteration is a general term for performing an action against each member of a group, one after another. What is a sequence? A sequence is a container of objects which are in a specific order. Individual objects of a given sequence are called identified by their position or index. What does the term mutable mean? If something is mutable, you can change it. Specifically, you can change the Python type without changing its identity, and I'm going to prove that to you in the upcoming slides. What does homogeneous mean? It means of the same or a similar kind or nature. In Python lists, this is typically so. It doesn't have to be so. So the items in the sequence can be treated with an appropriate level of unification. For instance, if your list includes all Python classes, you can do things to a class type that you might not be able to necessarily do to a different Python type. So if you mix and match those things, you could be employing methods or attributes that don't actually work or put your code in a position of not working as you would expect it to work. You should know that this is not enforced. This is not a rule, and it can vary greatly from one application to another. Let's find out some more about lists. Why should you care? When would you use a list? For any application where you need a list of items that you want to change or manipulate over time, and you care about the order of those elements, for instance, an employee list, a list of files in a directory, etc., a list may include duplicate values. That's another thing that not all Python types will allow for. You may choose to use nested lists. For instance, see here that I have x equals a parent list, an outside list with these outside brackets, these square brackets, and we'll see how to use these on the upcoming slides. And then I have these internal lists, right? I have grade 4, grade 5, grade 6, and then a separate list, age 10, age 11, age 12. It's all in that outer list. This is called a nested list. You don't need to have any elements, all of the one type. Right? We said by convention this typically happens, but you don't need to do that. You can have numbers and strings, for instance, in the same list. If in a different programming language you relied on arrays for a particular application, you're probably looking at using a Python list in Python. We talk about mutable types and immutable types on the previous slide. I wanted you to have a one-stop shop to be able to understand which of these types are in which category in Python. You may know of some of these, you may not know of some of these, but at least if you have this handy, it may be of use to you. So common immutable types for numbers, integer floats, and complex numbers, immutable sequences, strings, tuples, frozen sets, and bytes. And again, immutable are the ones that we cannot change in place. Then common mutable types. So that's almost everything else beyond what we just covered. So mutable sequences are lists and byte arrays, sets, dictionaries, classes, and class instances. And one trick to quickly test if a type is mutable or not is to use the ID function, the built-in ID function. We're going to see examples on the next slide. So we use the ID method to determine mutability. So look here on the left-hand side. I have x equals 10. So it's an integer 10. Then I pass the ID method x. And you see what comes back is a unique identifier. Then I change x. X equals x plus 5, or written this way, x plus equals 5. Now x equals 15. I now supply x to ID again. And look here, These are two different numbers, indicating clearly that these two objects are different. We didn't change x, we recreated x new. Then on the right-hand side, I have a list, apples, pears, and oranges. When I do an ID against lists, I get a particular number. Then when I pop that list, it removes oranges, and I perform the ID method again, feeding it L1, and you see that the numbers are exactly the same. So even though I have changed the content of the lists, since lists are mutable, we have the exact same ID, regardless of what's in this list. Okay, let's see about the different ways to create a Python list. Probably the most standard way to do it is through using the list display. We create a variable called my_list1, and then in square brackets, we have a set of objects. In this case, the numbers 1 through 6. When we then go to Python Interactive and type my_list1 and hit enter, our list will return, confirming that it has been created. The second way is to use the built-in type constructor. So here we have a string, Python lists, and then we declare list2 equals, and then the list type constructor, and in the list type constructor, we feed it string 1, and then when we print list2, we see that it has converted our string to a list. We confirm that by using the built-in type function against list2 and against string 1, and we get back class list and class string respectively. So this is a way that we can create a list from a string. And finally, the last way we'll talk about is through using something called list comprehension. List comprehension is a way to build a new list by applying an expression to each item in a sequence, really any iterable, and they are close relatives to for loops. In the example above, we are creating a new list from the string Python by repeating each character in the string 4 times. We're doing this by using the asterisk operator. The i's in this statement above represent each element in the existing string. So we create a variable new_list1, and then in square brackets we have that equal I times 4 for I in Python. Those i's, it will iterate over that string Python, and in so doing, it's going to create our new list such that each element will be repeated 4 times. And you see that's exactly what we have. So now let's look at the syntax on the left-hand side of the page and really kind of distill that a little bit. So new list equals expression for item in list if conditional. Right? It makes a lot more sense when we go through the example, doesn't it? But let's go through each piece. New list, of course, is the variable we will define that represents the new list we're creating from this statement. Now, it could be anything. It's user definable as long as it meets the rules and requirements of creating variable names. Then the expression is based on the variable used for each element in this existing sequence. Using that definition and looking at our example on the right, the expression there is I times 4. And again, I is every individual character in the string Python. That's what it'll wind up representing. So then for item in, the word for followed by the variable name to use from the expression to apply to the existing sequence. So I times 4, the expression, for I in Python. So that's where it becomes like a for loop, right? In a for loop, we iterate over something, and we're doing the same here. So I times 4, for I, the same I, they represent the same thing, right? It's always going to be, in this case, the characters in the string Python. You can apply an optional filter. We haven't done that here, but we'll see that in the slides that come up. Just a note about efficiency. List comprehension is faster than if we were using a for or a while loop because it's optimized for the Python interpreter to spot a predictable pattern during looping. Now, 2 more list comprehension examples. This one, we use a list called numbers that has 5 numbers in it, 1 through 5. Here, we again use the asterisk. Now, here's one thing I'd like to mention. This operator of the star or the asterisk, when applied to a string, it repeats. When applied to a number or an integer, it multiplies. So this particular operator makes use of this term called operator overloading. that's when it has different functionality depending upon what data types you apply it to. So I wanted to introduce that to you as well. So here we are in this example, I times 3 for I in numbers. So what is it going to do? It's going to traverse or iterate over every single element in that list, 1, 2, 3, 4, 5, and multiply it times 5. The resultant list turns into 3, 6, 9, 12, 15. On the right-hand side, we for the first time are going to use a filter. And the filter here is digit. So it tests to see if the particular character is a digit. If it is a digit, it's going to do something to it. If it's not a digit, it will leave it alone. So let's explore this. The original string, product ABC, 1, 2, 3, comma, product DEF, 3, 2, 4. So we have a grouping of letters, followed by a space, a grouping of numbers, a comma, and then the pattern repeats. So our list comprehension, numList equals S for S in original string if S is a digit. And the resultant list is what? It takes every single one of those integers and it creates our new list. It disregards the characters or the letters. So here's a question for you. Are you able in this example to identify our expression? In the example to the left, it was I times 3. Do you see what it is here in the example to the right? Do you have it? It's the letter S. It's our variable S. That's what the expression is this time. And what else can we do with lists? So here are a few other things. Concatenation of lists. So I have S1 and S2. I add them together and I can create S3, which is a combination of both those lists. Notice duplicates are permissible. Then on the upper right-hand side, I have indexing and slicing of lists, just like we use for strings, zero-based indexing. So the first element in the list is Fred. That's element 0 or index 0. So S1, 0 brings back Fred. S1, 1 brings back Rosie. And S1 minus 1 brings back the very last element in the list, Max. And then I could use striding. So I use the old colon and then a second colon minus 1. The same syntax that would reverse a string reverses a list. So you see the list comes back in the reverse. Then I can do the same, but instead of my stride being a minus 1, I use a 2 stride, which will take every other element moving from left to right instead of now right to left, right? Because there's no negative sign in front of that. So I get Fred, Henry, Max, the 0 index Fred, the 2 index Henry, and the 4 index Max, right? Every other one. Then I mentioned on the previous slide the nested lists. So this is just a different view of nested lists. And just to show you how we call those, if I call 0, 0 on my matrix, which represents the entire list, I get back the 1 from the very first sublist. It's the first sublist and it's the first element in the sublist. So if I do 0, 1, it's the first sublist, but it's the second element, number 2. If I do 1, 0, it's the second sublist, but the first element, 4. And if I do 2, 0, it's the third sublist with the first element, 7. Okay, so we can get into changing lists now. I have list 1. It has 3 elements, rice, PB&J, and broccoli. Sounds like a good sandwich, huh? List 0 equals barley is going to add barley in the first position. So now I have barley, PB&J, and broccoli, no more rice. Now I can delete and insert an element. So here I'm going to take a slice, list 1, 0, colon 2. So this replaces items in position 0 and 1, but not including 2, because the upper bound is always non-inclusive in slices. So now list 1 is corn, veggie sandwich, and broccoli. Then we can delete and insert nothing. So we do this by saying list 1, slice 0, colon 2 equals empty list. So now I replace items in position 0 and 1, but not including 2, because again, the upper bound is non-inclusive with an empty list. And here we're going to be inserting elements at a specific position within a list. So we have list 1, broccoli, soy milk, and broccoli. If we do list 1 equals broccoli, this statement with no indexing or slicing at all overwrites the entire existing list. So now list 1 is simply broccoli. list 1 colon 0 equals pizza and soy milk. When we have the colon 0, this is instructing Python to insert these elements at the very beginning of the list. So we have now pizza, soy milk, and then broccoli. Okay, so remember that colon 0 inserts at the very beginning of a list. Now here we'll look at some list methods that we can use. We'll start on the upper left-hand corner, and then we'll make our way down that list, and then we'll go to the right-hand side of the page. The append method adds an element to the end of the list. So we have list 1. It includes 3 elements, pizza, soy milk, and broccoli. List 1, we append tofurkey, and you see that that gets added to the end of the list. Moving down, we have the sort method. The sort method sorts the items in a list from A to Z. So capital A to capital Z, and then lowercase a to lowercase z. So the capitalized words get put to the front of the stack. So we have list 1, broccoli, pizza, soy milk, and tofurkey. We want to append apples. Now we have broccoli, pizza, soy milk, tofurkey, and lowercase apples. If we do a list 1 sort, you see that it alphabetizes on the words that are capitalized, and then it takes the lowercase words and it'll put them at the end. So apples gets to be at the end. Then we can do the extend method to add multiple items to the end of a list. List 2.extend zeal and peace. Then list 2 now has zeal and peace at the end. We have append method to add 1 item to the end of the list, and that's similar to what we saw above. List 2.append love. So now we have happy, joyous, blissful, zeal, peace, and love, peace and love lowercase. Let's move over to the right-hand column. The sort method may be modified by passing in keyword arguments. This is important. This is like giving configuration options. So the key argument gives a 1-argument function that returns the value to be used in sorting. So this pertains to the sorting. In this case, the string object's lowercase converter. So what happens here? We have list 1, broccoli, pizza, soy milk, tofurkey, and apples, apples in lowercase. List 1.sort using the keyword string lower. It in effect makes it appear to the interpreter that all these elements are lowercase. So it negates uppercase, lowercase. So then we have a true alphabetizing: apples, broccoli, pizza, soy milk, tofurkey. Now we can use the reverse method to reverse that. So it just happens in the reverse order: tofurkey, soy milk, pizza, broccoli, apples, right? Regardless of the case there. Now we use the built-in sorted method. List 2 is happy, joyous, blissful. We sorted list 2, key, lower, and reverse equals true. So all in one fell swoop, instead of having blissful, happy, joyous, we have joyous, happy, blissful. So a true alphabetizing in the reverse. So we can find an element's index or position. So list 2.index for the word love, and that is in position 5. Insert the word power prior to position 2. So insert 2. What do I want to insert? Power. So where do I want to insert it? Before position 2, the word is power. So we have list 2, happy, joyous, power, blissful, zeal, peace, love. Then we can pop the last element. That removes the last element. We pop love, and now we're left with happy, joyous, power, blissful, zeal, peace, no love. And we can also pop by position. List 2.pop2. That takes out the element that would be in position 2. And in this case, that is power. This will be our last slide on more fundamental concepts, methods, and other things having to do with the list object or list data type. So upper left-hand corner, the count method counts the number of occurrences of a specific element. So we have list 3 with a bunch of numbers. List 3.count the number 1, and it tells us it appears 4 times. Then we can test for membership in a list. Does an element exist in a list? So we ask 4 in list 2, 3, 4, 5. It returns, of course, true. X equals 1 through 6. Is 7 in X? 7 in X? False. So to the right-hand side, there's the notion of referring to a list and copying or cloning a list. What are the differences? This is a topic that often gets asked up on Stack Overflow and through different methods. Referring to a list makes a second instance of the list, but with a different name. So list 1 is A, B, C, D, and E. If I say list 2 equals list 1, now if I show list 1, A, B, C, D, and E, list 2 also is A, B, C, D, and E. If I pop the E from list 1, List 1 is now ABCD, and lo and behold, without doing anything to list 2, it is the same. Why is that? Let's do an ID to understand what the OID is, or the object identifier is, for each of these. List 1, you see, is the same as when I do an ID for list 2. They refer to the exact same numbers. So they're the same element. They just have different names or two different labels. Now let's contrast that to copying a list. One of the easiest ways to copy a list, there are a few, is to do a slice. And it also is the most efficient. I have a note at the bottom that helps us to understand what is the most efficient way. The fastest way to do it is through slicing. So this method we'll walk through now. So list 3 equals list 1, slice the whole thing. So list 3 now becomes A, B, C, and D. If I do an ID on list 1, I have the same number as before. But lo and behold, I do an ID on list 3, and it's a completely different number. If I list 1 pop D, now list 1 only has 3 elements. The D is gone. List 2, same thing, but list 3 is unchanged. Why is that? Because it's a completely different element. It's a completely different object. Now let's look to the left. Copying to a list, the second method. We can also use the copy method to copy a list. So let's introduce list 4 to copy list 1. List 4 now has A, B, and C, which is where list 1 left off in the right-hand column. I do an ID for list 1. It's that same old OID. I do an ID for list 4, and it's a completely independent identifier. They are 2 different elements, 2 different objects. Okay, and as previously stated, here we're going to get to some more advanced topics. You may want to take a peek if you're new to Python, just to see what's coming up or see what you can glean from this. But don't get overwhelmed. If it's too much, just simply go to one of the other training modules that speak to some of these topics that are now combining the knowledge that we have with lists with other objects across Python. Our objective here is listing items in a directory. So we start at the top. And to do this, we want to make use of some of the functionality that comes with the standard library. So to do that from within our own script or with our own context, we have to do what's known as an import. To import, we use the import keyword. So import OS. I'm telling Python that I want to make use of the functions and methods within the OS module. So import OS, then I have a variable equals os.listdir. And listdir enables me to see all the elements in my particular folder or directory that I'm in right now. If I wanted to change the position and point it to a different directory, such as users, my name, documents, I can do that as well within the parentheses of the listdir method. And you see that I get a different set of elements returning. Now we're going to filter for files only. We're going to use this with list comprehension, which we looked at earlier. So just files, name for name in os.listdir, and I give it that same path as previous, if ospath.isFile. Right, so I'm saying to the interpreter, I only want it if it's a file. Then I use the ospath join method. Once again, pass it the directory I'm interested in and our iterable name. So the join method is a string method that returns a string in which the elements of the sequence have been joined by a string separator. The parameters for join method, it takes an iterable, an object capable of returning its members one at a time. Some examples could be a list, a tuple, a string, etc. The return value, the join method returns a string concatenated with the elements of the iterable. So you see, when I fire off our variable just files, I get there only elements that are files, only elements that have an extension, a dot, whatever the case may be. To find just directories instead, I would employ the isdir method instead of the isFile method, right? That makes sense. Now, continuing with our theme of listing the items in a directory, the top example does just that, and we want to get files, but in fact, we want to get just one particular file type, and those are JPEG files, so .jpg. So let's see what we do. It's not too much different than what we did before, but we are using a different filter. JPEG_files is the variable that we create. Then we have in list comprehension, file for file, our iterator, in os.listdir, and we've seen that before with my same directory. If, here's our filter, file, our iterator, dot ends with a new method, .jpeg. So we file off our JPEG files, and we get the two files, the only two files in that directory, that are of type JPEG or .jpg. In the next example, we'll list additional metadata such as our file size, the modification date, things like this. So we have three import statements. Let's deal with those first. Import OS we took on the last page, and even import.os.path we used on the last page. But let's look to see what that's all about. The OS path module implements useful functions on path names. So os.path get mtime returns the time of the last modification of the path or the object. The return value was a floating point number given the number of seconds since the last modification. The os.getSize returns the size in bytes of the particular item. Then we use the glob module. The glob module finds all the path names matching a specified pattern according to the rules used by the Unix shell. So it's ported over from the Unix language, although results are returned in arbitrary order. Okay, so those are our three import statements. Now, we create a variable pi_files equals glob.glob. Again, we're using the glob function from the glob package. And then we throw it our same string, except we do a star.py. Now we want only files that end in py, so Python files. So then we have a name size _dt equals files, os path get size for the files for that iterator, os path get mtime, right? The time was modified for that iterator, for files in where? The directory that we just defined, the my_files. Then we have a for loop for the name, for the size, and the mtime in name_size.dt. That is the list comprehension. And we print name, size, and mtime. And you see that's exactly what we get. We get the full path, including that Python file and only Python files. Then we get the size of the files in bytes, and then we get the time that it was last modified. Now we're just going to do some listing with loops. I know if you're following our Python Made Easy series, we haven't gotten to loops yet. But again, try to see what you can glean, see if you can follow along. And if there's any frustration, go over to the section on loops, and that should clear it up for you. Okay, so starting in the upper left-hand corner, we're going to print all elements in a list using a for loop, a very typical use case. So dogs, Bubba, Pooh, Ellie, Fred, and Fefe. Those are some of the dogs I have now and that have passed on to the other life. For dog and dogs, print dog. And you see it just simply prints that out one after the other. Now, moving down, we'll use the built-in enumerate function to retrieve both index, so the position, and the value. So now we need two iterators, for I, v in enumerate, right, a new function, dogs, which of course is our list, print I, v. So we see Bubba is in the first position, Pooh is in the second, Ellie's in the third, etc. Now we're going to pair elements in two separate lists using the zip function. So we have a list of dogs and we have a list of cats. So again, in our for loop, two iterators for D, standing for dogs, and C, standing for cats. In zip, dogs, cats are two lists, print D and C, each iterator. So we have Bubba paired with Felix, and Pooh paired with Snowball and Ellie and Moonpie and Fred and Killer and Fefe and Turtle Dove. Boy, we got a whole bunch of fur kids going on. Moving to the upper right-hand side of this page, for in range 10. In n mod 2 equals 0, print n. So what are we doing here? And if you've been following our series, a lot of this will look familiar to you. If n, an item in our range of numbers 0 to 9, is divisible by 2, is what we're saying here. That is to say, it will have no remainder, aka n mod 2 will equal 0. If that's true, then print it out. If not, then don't. So you see that's exactly what we get in our range of 0 to 9, right? Note, because it's 0-based indexing, the numbers start at 0 and go through 9, so 10 doesn't get printed out. So we get all the even numbers, 0, 2, 4, 6, 8. And now let's see this. We have new list, and it's an empty list. So now what are we doing? For loop in range through 20, so that'll be 0 to 19. If the item is divisible by 3, append to new list times, so that particular element in the list of the range from 0 to 19, times 2. So only if it's divisible by 3. So we get 0, 6, 12, 18, 24, 30, and 36. And we'll end with the most complicated by far. We're bringing in a lot of different concepts. Some we've spoken about, most we haven't spoken about if you're following along with this series, but see what you can glean. Let's see how well I can explain this. What is our objective? We want to list objects in a specified directory, get the size of each, sort by the size, and then count the total records. Those are all the things we want to do. So let's take this code over the next several slides, line by line. First, up at the top, I import specific modules from both the Python standard library and then one from outside the standard library to make use of their functions and modules in this code file. Next, I create a function called file size where all my code will live. I do this instead of writing straight code so that I might make use of this functionality again some point in the future. All I have to do to make use of this is to import the file into the new code that I would create. Then you see here, we have a doc string, and that's in between the triple single quotes. This gives information about your code and how to use it. It's good for developers who may pick up your code and also for you to remember what you did and how you did it. I defined a variable called basedir. This represents the directory upon which I want to run this code. The lister method returns a list containing the names of the entries in the directory given by the path. And we've come across lister before in this training. The next line joins one or more path components intelligently. The return value is the concatenation of the path, which is, in our case, represented by basedir, and any members of the star path, in our case, represented by iterator name. So this joins the basedir path that we will supply to each object, represented by names, in that directory that we specify. Then in the next line, the OS module provides a portable way of using operating system dependent functionality. The stat method is one of many that performs certain operations on files and directories, and in this case, we're using stat size that gives the size of objects in bytes. This is one of the many data points that stat collects and that we can make use of. Moving right along in our same script, the next thing that we see is an empty list, and we call it pairs. After that, a blank print statement that will skip a line at the console is executed, and then a series of other print statements that will print literals as you see them there. Next, we have a for loop that cycles over each object. F is each path and file name, and S stands for the size. And then it appends them to the empty pairs list I created above. Finally, I use the sort method on the newly created pairs list. Then I use what is known as key function within my list. It's a way to call each element of the list and then to do something with it. In this case, sort. I feed the sort a lambda expression as my key. A lambda is an anonymous function. Again, something else we haven't covered quite yet. The argument I feed it is each individual file size. So that's through S position 1 from my loop above. S1 is the second element. F is the first, F0. This is telling it to sort on that second element, which is the size of the file. That's exactly what we want. Almost done now. You still with me? Okay, here we have count equals 0. This is an integer named count that I'm setting to 0. This will be used as the basis to be able to count how many elements I have in this particular directory. Next, this is a second loop that we will use, a second for loop that will be used to return my output. X here represents the file path name and Y the size of the file. Then here, I use Python string formatting against each element in my loop to make it line up and look pretty. See the introduction to Python course, which goes into this in depth, this string formatting concept, if you're confused at all. This now prints the formatted output. This next line translates the size in bytes to something more readable and relatable using the hurry.filesize external packet. Note, this keyword size here against the variable or iterator y, this is what makes this translation possible. Also, you see system equals alternative. This is a configuration option that hurry.filesize gives us. I think it just looks a little nicer, and you'll see on the next slide. Then my counter increments each time the loop is run and adds one more to the count. This is what tells us just how many objects we have in the directory. Then this prints my last value of count. This will be the total number of objects we have in the directory after everything has been run, after they've all been gone through. This here is the caller. This is what starts the whole entire thing running. With a function, we need something to call it. Without this, the code would never start. I used the sys.argv number 1 as my argument. What is this? This aligns to the specific directory I want the file sizes on. I do it this way, so each time I run this file from the command line, I can add any path I want. We don't want it hard-coded. We want the flexibility to change this so we can use it on any given directory at any time. Finally, these last 2 lines print a string literal and then the doc string for my function called file size. And here we'll see exactly how to execute this file, and then we'll see the resultant output. So this first line right here, notice a couple of things. I start with Python 3 to call the Python interpreter. Then I input the name of the file itself, where our code is captured. And finally, this is the directory we want the file sizes on. This is represented by our sys.argv1 in our code that we just spoke about. Now when we press enter, we get all this wonderful output. We get some of those string literals, folder sizes printed, plus the equal signs going across the top. That's just my way to make it easier to read. Then we get all our file output. Notice how the Python string formatting separates one element, the file name and the path, from the actual file size towards the right-hand side of the printout. Secondly, see that each line record has the translated easy-to-read size from the hurry.filesize external package. So I have 96 bytes to the right. I have 96 to the right, rather, and then I have file size translates to 96 bytes. And here is just another view of the output. I just wanted to show you that we did indeed count the total number of records, which equals 78 in this particular case. And finally, we printed out our doc string as the very last thing. All right, so that's the end of our training class on Python lists. Please leave me some comments. What did you like? What didn't you like? What was effective? What's not effective? I take your comments very seriously, and I try to improve this course content. If you did like it, I'd appreciate a like, and I'd appreciate you sharing this on any social media channels to get other people to this Python Made Easy series. That helps us all in the end. So keep breathing and code, folks. I'll see you in the next one.